Good morning and afternoon, everybody. My name is Shaun McCullough. I'm very excited to be here with you in this nice December day. It's actually rainy and gross outside, so I'm glad at least I'm here nice and warm. Um, we're going to be kicking off a series of conversations about threat detection engineering, emphasis on that engineering in our cloud environment. We're going to take different kind of approaches when we look at each one of these. Today, we're really going to be looking at kind of like what is detection engineering? What does it look like? How do we apply it to the cloud environment? And we're going to walk through a particular attack and kind of how we use that attack as a starting point for us to figure out how to implement better detections inside of our environment. So, without further ado, we will get into it. Just real quick, my name is Shaun McCullough. I work at GitHub full time. That's my day job. Um, uh, I am also a SANS instructor, and I'm one of the authors for the SEC 541 Cloud Threat Detection class, which I just realized we've name has changed a little bit, but it's the Cloud Threat Detection class. And before that, I spent 20 years at the NSA doing cyber operations. One thing I like in my career, I've kind of go back and forth. I've done management, I've been technical lead, I've been project lead, but then what I really have enjoyed is when I do software development or security, and if I can combine those two together. And so being able to do that over the last, I don't know how many, 30 years I think now that I've been paid to do engineering work. I really love that ability to combine that security, that operation, and that software development. And that's one of the reasons when Amazon, I started working with Amazon. I was like, this is the greatest thing ever because there's so much that I could do to automate and build and create infrastructure, not just individual, like apps or something like that. I could really do it with the infrastructure, and that is really kind of why I really loved the cloud and started getting into it. One thing I should mention, I will have time for questions at the end. So if there's like a QA part of Zoom, if you go ahead and just ask your question, and at the end we'll take care of those questions. So please feel free to do that. All right. Let me do one thing real quick. Let me pop that out. All right, good. Sorry, I'm pulling up my chat so I can see it when I go into. All right, so we're good. All right, so let's talk about this. Why do we have detection engineering as a separate thing? Like, I mean, is it a discipline? Is it a process? I mean, there's a lot of ways in which people kind of couch it. One thing I would like to just kind of say outright is that I always believe that it is best for you to take nuggets of information from different places and apply it to how it works really well in your environment. So, what looks like a practical deployment of detection engineering in my place does not maybe match what looks like in your place. So I've tried to take this and make it a little bit generic in terms of this process, but the intention is to try and figure out how to implement this inside of your environment. There are companies out there that will say, this is how you do detection engineering. They're usually selling something like a process or a tool that matches that process. You got to kind of figure out in your own way how you're going to do things. So just kind of take that from a grain of salt. So, in detection engineering, there's a couple different steps. Before we put this engineering on the side, I've worked at places or I've talked to people who worked at places. One of the nice things about teaching for SANS is I get to meet, thousands of people that all have different approaches and companies are doing things differently. And I hear the good and the bad for them. And I remember talking to one team, and they were analytic developers. They had access to their SIM, which was Splunk or something like that. I don't remember which one it was. Doesn't really matter. And what they did is they wrote alerts, and they also did investigations, but they had no control over what data they had access to, and they actually had no insight into the infrastructure itself. So they didn't really know how organizations were running things. Boy, that was just such a terrible position for them. And I hopefully you're not totally in that position where you're trying to write detections or analytics on something you don't really have full control over the data, the what kind of data is coming at you, how often is there any gaps, all that kind of stuff. And so when I look at detection engineering, I'm looking at it as, hey, a team or teams of people working together. They are determining what data is needed, what analytics they're going to write, how efficient those analytics are going to be, what the false positive rates and things like that you're going to allow. Being able to tune those to work inside your environment and to test that process over and over again. So it's looking at the entire thing. Now, it doesn't mean that one person's in charge of the whole thing. You might have one team that writes the analytics and the team next to them is the one that gets the data, but they're working together to kind of do this as a full process. So detection engineering is this idea of building your detections, testing them, and then constantly improving them. I got a detection that's running and it's just firing false positives all the time. There's a problem. You need to go fix that, right? SOC is overwhelmed with these low quality alerts. As mentioned, we got to figure out ways to maybe grab the data, but not look at them and respond to them at all times. I need to go pull that data. I need to build some better analytics on top of the alerts that are just flying at me. Our detections have to be customized in order to handle, try and kind of tune things to the environment, and our environments are changing significantly. It might be that a new team has come on board and they're going to do things differently. In our cloud environment, that happens a lot. When we moved from on-prem into the cloud, we were able to start giving dev teams more control over how things are deployed, for good or bad, right? I mean, there's two ways of looking at that. It certainly allows us to deploy products faster, right? So it's been helpful in that case. But it also means that what you're doing today does not look like what you're going to be doing next week. And so being able to tune those detections, customize them maybe for a certain process or for a certain team. This team always has things on the internet. This team does not. So if I see something on the internet, I'm probably going to focus and throw those alerts faster, but only for them, right? Not for them over here. So being able to kind of do that makes it helpful. And then that means our detections are constantly evolving. And so being able to do this requires kind of a different approach than the whole I'm just looking at a SIM. I don't have control over my data or my infrastructure, and I'm just going to write whatever I feel like, right? That doesn't work anymore. So we need to do something. So that is kind of what I look at is why engineering has been added to that end of that detection and for that detection engineering. So what is our process for a detection engineer? So in our detection engineering process, I'm going to identify the attack technique I want to focus on. Usually, I want to try and do that based off of some threat that my organization might be vulnerable to. That threat might look different than your threat. If you're a bank or a healthcare, your threats look a lot different than a software development company, right? So you're going to kind of have to think through these things a little bit differently and skew them for your environment. One thing that is nice if you're in the United States is that if you're in a large organization, you might be part of an ISAC. And those ISACs are, groups of companies that are in the same business vertical, and they likely share some level of data. I've seen ISACs that share all kinds of threat data. I've also seen some ISACs that didn't share anything, so that's unfortunate. But there are some opportunities for you to figure out that, hey, I'm the financial sector. Like if you're in the financial sector, your ISAC is sharing great information about threats. So go and use those as a place to figure out what your threats look like. You might also be identifying these attack techniques based off of your vulnerabilities. Maybe you're really good at data encryption, but you all are very bad at network control over your cloud resources. And remember, I'm really talking cloud. This could extend into on-prem as well. But I feel like the cloud, it's not that the tooling makes things different, but the way we control the resources is different. And that makes for more complex environment, I think, in some cases. And so you might have some teams that are really good at one part of your lockdown and some parts that are not. So being able to identify the attack techniques that might be most vulnerable to you and one that attackers are going to use against you is going to really help kind of focus that in. All right, you're going to figure out, make sure that you have the right telemetry, which is alerts and logs. Did I spell telemetry right? Yeah. Sometimes I look at a word, I'm like, did I spell that right? And then somebody always tells me I spelled something wrong, but telemetry. Yeah, I'm sure good there. Uh, that telemetry data sometimes is very raw data. So if I'm pulling in, I don't know, access logs from Microsoft. So every time anybody does anything with the API to create, delete, update, I'm going to get all that data. Most of that data is not useful, and it's just going to sit there. So I'm not going to alert on all of it. But I might have data that is, let's say, threat data that's coming from Defender or coming from guard duty that might say throw in a place and say, hey, this may not be a big problem, but it looks a little awkward. So let's go and figure it out. And that's telemetry too. I don't think you should automatically react to every guard duty alert that you get or Defender alert, because guard duty and Defender don't have a good idea about your environment. And they don't know that it is okay for this particular team over here to create S3 buckets that are publicly available to the internet. That's kind of their job. And so you might have an alert from Macy or some other kind of tooling that says, hey, this is happening, it's a problem. And that's okay. Being able to tune that, filter that, maybe stack a detection with log collection to be able to tell a higher fidelity alert, that's going to be really important. So I got to get that data into the right place. I don't believe that all of your data should go to your Splunk instance all the time or whatever it is you're using for your SIM, because there's a high cost for that data. Pulling data out of your cloud environment into your on-prem, you're paying for that data exfil. So that is a problem. You are also you're also paying for the storage, and also your Splunk instance or whatever you're running, you have to pay for the upkeep of that. So if I have a lot of data that is unusable, really, most of the time, I don't have any detections on it, it might be easier just to keep that in your maybe your storage account or your S3 bucket and be able to run queries against it as some kind of action happens that you need to go and investigate it. But if you're going to do a detection and you have a detection engine, some kind of tooling system that you've built or you're leveraging from your third party software, likely embedded with your SIM or whatever it is you're using, you're going to probably need the data that you want to write detections for in that right place. And so you got to kind of think about how to get that data. If you're going to do any data transformations, maybe you're going to limit some of the data so that you're reducing your cost. There's all that kind of stuff, which actually we won't talk about today, but that's a whole kind of focus area you got to think about if you have the resources to do it. You're going to build your detections, and then you're going to test them all the time. There are unit tests that you can do, and then there's integration tests. So, and then I'm a software developer, so those are software development terms. But the idea of a unit test is on your computer, can you somehow test your detection? Can I run an analytic, pass it data of an alert of, like logs, canned log data, and see that, yes, it's detecting. That's what I expect. That's a unit test. That's great for building, but it may not work real well in the real world. We don't have any control over the way the cloud provider is creating data. They can change the data out from under them. If anybody's ever used AWS Inspector, they changed the data right out from underneath me one time, and I was like, I still don't understand, can't find the data, the information that describes why their schema changed. So that data can change, and your alerts will stop firing, not because that there's no activity, but because something's happened on the back end. So you need to be able to test it in your production environment or as close to a production environment as you're willing to get, which means running attacks inside of your environment. That could be through a red team or hopefully through some kind of script that you've written to perform the actions. That's what kind of, what we do and a lot of places do. And we start trying to find ways of building and deploying those detections in a repeatable manner through software, which we'll mention. And then you want to deploy your detections, measure your detections, and you want to be able to track, hey, when this detection happens, did any resulting investigation happen? And start kind of tracking that data, because as you'll find, you'll realize that, hey, there's not actually a lot of detection or investigations happening. Most things are false positives for this particular detection. I probably want to reduce its priority level and not look at it all the time. So this last line of measuring is, I think, the most important part of adding engineering to the detection building process. Engineers measure everything, and they take samples and they evaluate all the time, all the time. Can I improve? Can I improve? Can I improve? And you need to be doing that in your process at every step of these four that I'm talking about here. You need to have measurements to investigate, to figure out, am I doing the right thing? And am I doing it at the right volume? So Do I have enough detections in place? That's kind of hard thing to measure, but how many detections do I have in place? You could probably measure that. How much of the telemetry that I'm collecting is actually useful? Am I spending tens of thousands of dollars a month storing data that nobody cares about? Are my detections failing quite often? Do my detections have a lot of false positives and thus wasting time for people? All that measurement is very, very important. All right. So let's talk a bit about a particular attack. Midnight Blizzard happened against, well, Midnight Blizzards happened against a couple different places, but this is specifically against a Microsoft environment. And I'm not intending to talk about every step. I just want to use this as an example of how you would build out some detections inside of your environment. I do have a little bit of, I'm getting over a cold, so you can see me drinking a lot today. Just keep that voice going. All right. So in our Midnight Blizzard, this is kind of our layout of our environment. We had a test. There was a test environment that Microsoft had, um, and it was a test tenant. So there's Microsoft test tenant, test account, and AWS, whatever you want. There's different ways of couching this. This is kind of a Microsoft story, but it doesn't have to be. The kind of conversation we're having, you can apply to your AWS or GCP. Then there was a production environment, and there was a trust between those two environments through an application and a service principal. Basically, an application in the test environment had access to the production environment. Now, um, that happens quite often. And sometimes that happens because somebody was doing something and then they stopped doing it. They forgot. They left the company. Maybe it was for a product that no longer exists. And so you're going to have trust relationships in and out of your environment. So that's kind of a thing. So we just go back and look in your own environment, and I'm sure you're going to find it. All right. So let's walk through this step by step. So first, we had the attacker did a password spray against this test environment. Now, Microsoft has making a change or is rolling through a change that will basically stop you from having access to your environment without multi-factor authentication. This is actually a lot of work for some organizations, but boy, it's going to be great when you have to have multi-factor authentication. There will be other ways this attack can happen, but just maybe not through a user account, like a human account. Those are the things that are going to have the multi-factor authentication. But in this particular case, the attacker did some kind of password spray, guessing these passwords against these accounts, and they were able to gain access to a legacy account inside of the test environment. They were snooping around and they were found a OAuth application that they had access to. Now, there's a lot of different ways this could happen. It could be that there were credentials. It could be that this was an Azure function, maybe, or a container or a virtual machine. Like there's a lot of different ways in which there can be a compute or an app or some other kind of service like that that has access into other environments. This was in particular an OAuth application, but it doesn't have to be that case. So one of the things that I would see most often is maybe if you had an application that was shipping data. And so it had to be able to engage and take into the other account. It has to go and get permissions in that other account. Maybe it's a serverless app or some other kind of app. The numbers below these, the words is the MITRE attack technique. I try to identify the technique that was as close and as common in these kind of particular cases. In this case, the execution of a serverless app, T1648. And this application had been given permission to assume a service principal, which is a credential, in another account. And so they could go into the other account and perform some activity. I said account, should say tenant because it's Azure. If it was AWS, this could be into a different account. In AWS, there's organizations, right? And so the organization has multiple accounts. You might have multiple organizations. This happens because your company might have bought another company, or you might have found out that somebody had spun up their own tenant, not really realizing what they were doing. And after a year, they actually have production code running, and it's really hard to move that. And so maybe you have these kind of environments that have been stood up, and you're like, I got to kind of keep them. Or you've decided to split your test and your production up, and you're not segmenting them as carefully maybe as you would like. So There's different ways in which this would happen that would be legitimate. But whatever the case is, the attacker was able to use some authentication from one side to get into the other side. Now, strangely, that other principal, that other credential in the production environment had the ability to create new personal accounts or new people accounts. That is the one that kind of throws me in most from a policy perspective, but we've seen attacks against really great security companies or companies that have really great cloud security. We've seen them happen because of a misconfiguration somewhere along the line. So maybe they didn't intend to have that service principal have the ability to create accounts, but in troubleshooting, they did like a allow all just to test it, and then they have to go back to fix it. That happens a lot. I might have done that myself, actually. So even people who do this for a living, this tends to kind of sometimes happen. So you got to be careful of that. All right. So I've got my attacker was able to create that account, and then they use that account to perform more actions inside of the environment. All right. So let's take a look at that. Sorry, I was going to sneeze. What could we do a detection on? Now, there's a lot of things that we could do detection on. There's no one right answer for this. We could look for people logging into a legacy account, like that password spray. If we had been looking at it, if you had Entra IDs turned on and you had all of its detections turned on, Entra ID might have detected the password spray. But maybe the attacker was going low and slow. This was an advanced persistent threat. I always say the advanced persistent threat is named that because they have the time and energy to go after you specifically. And if they have the time, they might do things slowly. So maybe this wouldn't have been able to be detected. But you're not going to really look for anybody just logging into an account unless you have some kind of detections on top of that that says, hey, listen, nobody should be in this account except for these 5 people during these timeframes. One thing I would say is that from your detection, you don't have to always detect bad activity, but you could detect activity that is high risk and go and have a human validate that that activity is being done by the right person. I like that idea for things like, creating accounts, maybe. Logging into legacy accounts probably wouldn't do that, but making a change to logging, like the security logging, if someone makes a change to the security log, maybe that's me doing that as part of my job, and that's okay. But I like it when our, detection team might call me and say, "Hey, is this what you're doing this? Is this you?" And they go, "Yeah, this is me." And that's great. It's just another person doing a validating check. So it doesn't always have to be an automated, this is the attacker being bad. It might be, this is a high risk activity. Can you double check to make sure this is being done by a person at the company with good reason? So logging into the legacy account probably would not write a detection on that beyond turning on things like password spray detection. Accessing the OAuth app, I mean, that's kind of what the OAuth app is there for users to access it. So the fact that it was in a legacy account might look weird. This is the case where maybe instead of uh, detecting that the activity is happening, your security team on a regular basis goes and double checks to see if there's any accounts that or any apps that are not used in the last 3 months or any credentials not used in the last 3 months and deletes them or disables them or something like that so that an old account that's been sitting there doesn't get detected. Or doesn't get used by an attacker. In an old on-prem days, we used to joke about like the the account that's sitting underneath someone's desk that nobody really knows who owns it, and it's not turned on. Let's turn it on and see what happens. Well, it actually is probably not patched. It's not managed. Is it on the internet? Does it have sensitive data? I mean, we don't really know. No one's actually looking at it. You want to make sure that you're always looking at your action or your activities, identifying which resources are being used and which ones are not being used, and trying to kind of double check and say, hey, can we delete these things that are not being used? But I probably wouldn't do a detection based off of an OAuth app being accessed. Now, cross-tenant access is one that might be. It is likely that there was an intention for an app to be able to access the tenant, a different tenant. That's how it was set up to do that. You had to purposely create that, but it may not have been something that is happens very often. So I could write a detection that looks for that kind of activity. Um, The problem is you'll have a lot of the activity that is acceptable. So, like your third-party applications that are interacting with your cloud provider, whatever your third-party products are. OAuth would be one, right? I mean, it is actually an external access, but it's valid. So maybe if you have a really good way of tuning it, but that could be a lot of false positives. The last one, though, creating a new account, that might be interesting. Who is allowed to create accounts inside your environment? Is it through a centralized process, or can anybody create an Azure or an AWS account? Um, that's kind of up to you. One thing that definitely doesn't happen often is maybe an attacker who creates an account and the account doesn't look like all the other accounts. Maybe that's something we can look for. So let's dive in to that one in particular. Sorry. All right, there we go. Okay. I went one step too far. There we go. All right, so let's take a look. Maybe only a certain team can create detections inside or create accounts inside your environments. Maybe it's through a CIC process, which I hope is the case. And then you can see that a service principal that is not one of the approved ones has created an account. That would be a good detection. Um, Maybe the kind of account, if someone creates a global admin, that is definitely a problem that should hardly ever happen. And that's a good time to maybe pick up the phone or I guess text and chat to say, hey, is this what you intended to do? One thing that some focus had been on is the short duration account. So something was created, maybe they created an account, that account was being used to do a bunch of other things, and then the account was deleted to try and kind of stop the investigation. And so there people have been written up how to detect this, and there has been some queries that have been created. So let's do that. Let's look for an account that was created for short duration and then was disabled. Now I'm talking about Azure accounts specifically and AWS. These might be IAM users. Um, Man, IAM users in AWS are terrible. We really shouldn't use them anyways. And so this might actually be a different kind of service, like a cross account role. But in Azure, you're creating human accounts, possibly, likely, inside that environment using Intra ID, and you're connecting it maybe to Okta. But creating an account, then deleting the account should not happen very often unless you have some specific need and you can kind of bounce those out. There's a website, I'm going to pull this query from. I didn't write this query on my own. And we're not actually focusing on how the query works. We're really kind of talking through this process here. So there's this query website, github.com/Azure/Azure-Sentinel, which are Sentinel queries that let you write detections. And one thing I really like about Microsoft is that Microsoft's detections that they provide through Sentinel and everything, you can see the entire query. And so you can make changes to them and you can customize them to work inside your environment. I really like that. I don't have that ability in GuardDuty, which is unfortunate because I would love to be able to tune GuardDuty alerts and maybe make them not so sensitive in some cases. So there's one in particular called account created and deleted in a short time frame. By default, it's within a 24-hour period. Let's detect when that kind of thing happens. All right, so let's go back through our process of detection engineering and walk through it with this particular example. First thing I'm going to do is go gather the data. Now, for creating Intra ID accounts, which is really what we're talking about, user accounts, that is going to be in the Intra ID activity logs. And I would turn that on through diagnostic settings. One of my benefits of Microsoft as opposed to AWS is that I can go to a centralized place for any kind of like policy deployment, user creation, that kind of stuff is all centralized in the Intra ID. In AWS, it's a little bit more complex. I might have to go to each account to go turn on logging. But one of the things that with the Entra ID is I have this thing called diagnostic settings. And one place I can go and I can turn on the diagnostic settings for it. The other problem though is that in AWS, or I'm sorry, in Azure, I might have to go to individual resources to turn on logging. So Entra ID is a centralized resource. There's really only one per tenant. So I'm going to turn on the logging in one place. That's great. But if I wanted to turn on activity logs against the environment, which I do, I want to turn on my Azure activity logs. I got to go to every subscription and turn it on. Luckily, I have something called Azure Policy that allows me to fan that out and do that, but it's still Azure Policy having to go to every individual place and turn on a setting and then tell the setting where to send the data. And so there can be problems with doing that. So you just got to keep that in mind with gathering the data. We'll hit it kind of how to get around that. In AWS, a lot of logs can be collected with CloudTrail. And so I can just turn on CloudTrail. I actually can turn on at the top of the organization, and it will fan out to all the individual AWS accounts, which is really nice. And so there's one way I can do it. So there's pros and cons between Azure and AWS in this world here. One thing to keep in mind, though, is treat your log collection like a security requirement. So have alerting turned on that says, if I have an Azure subscription or if I have an AWS account that does not have logging turned on, then throw an alert. Like I would, someone's deployed an insecure virtual machine, right? That kind of security alert. And have that come back to your security team, whoever's in charge of this, so that they're part of that process so they can say, oh, I've got a problem. I got to go investigate it. All right. So I'm going to go to my in my Azure policy, and I'm going to turn on my logs. So I can turn on a bunch of different intra ID logs. This is not all of them, but just can give you an example. This is through diagnostic settings. It looks like this for all of the resources as well, which is really nice. They all have kind of a similar feel, which makes it easier for doing automation. They're not exactly the same though. There's like differences, which is just mind-boggling. But anyways, the one that I really care about is my audit logs for Intra ID. I'm probably also going to want to get my sign-in logs. Actually, let me pull up my pen laser pointer. So my audit ID logs. I might also turn on my sign-in logs. Then there's different kinds of sign-in logs that I can look at. Service principal sign-in logs. So this would be the service principal, the snowman that I had that didn't have the hat and all. That is a long-term credential usually. And that long credential has key information or secret information that's stored and being used. I can look at just those sign-on logs too. So I've got kind of this really one quick place to go and look to see all the stuff and turning on all the logs. All right. So then I got to tell it where to send the data. I'm going to send it to my log analytics space, which is a really nice, really great built-in service that allows you to write analytics inside your environment. I can specify my subscription. This is a snapshot we took from our cloud class. Just so all the labs are based around the world of Sherlock Holmes. That's why it's called Sherlock here. I can also store my data to a storage account, which I probably would do for long-term storage. And I would do this in a security subscription that is blocked off and heavily monitored. So I could turn that on. And then that data is going to show up in my log analytic workspace. So all those diagnostic settings I had, I can see them right here. I can run queries against my audit logs to figure out when things have been created. I can also turn on alerts from here. Actually, I would take Sentinel and I would point Sentinel to this log analytic workspace, and I would write those analytics from that web page that I showed you. All right. The data, as I said, needs to be accessible. If it's in log analytic workspace, it's very accessible. One thing is that some of the data, like network security group logs, are actually transformed to make them more queryable. If I just store that somewhere else, I'd have kind of a pain to go and pull that data. But log analytic workspace will transform that data. But it's expensive. So you're paying for that data being stored in log analytics workspace. You're also paying for the indexing of that data so that the queries are really fast. So it's got to be data you really want. If it is a SIM, if this is where you're going to do your queries, makes sense to do it here. If you're going to send this stuff to your Splunk instance, there's a different path, which we won't get into today because it's just too much. But you have an option here to do it. In AWS, there is not as good of a tooling to do querying and analytics, but you can send your AWS data to Microsoft, so to your Azure environment if you want to. So there's ways to do that. So you got to make sure, though, that your data is accessible to the people who are going to run the queries, and also they can use that for investigation. Tell people where your data is. So it's kind of easy to go to this particular log analytic workspace and see this data, but there's going to be custom logs that you can be collecting from other places. There's going to be application logs. You can have different log analytic workspaces. It doesn't have to just be one. So one for the security team, that makes sense. But then you're going to have one maybe for your, I don't know, your ops team, right? To monitor virtual machining activity, right? So that's going to be a different place. For your security team specifically, you need to identify what logs you've turned on, where those logs are going. If they're going here, if they're going to a storage account and I'm using some other kind of service, if they're going to my SIM, what is the index in my Splunk? You need to have that documented really well. Know who owns the data. And when I say data ownership, what I mean is, hey, who is the person that's going to be writing queries or doing investigations for Azure activity logs? Because you want to know, am I getting you the right data? Do you have the right coverage? Is the data, in the right, is it set up the right way? Are you actually using it, or am I wasting time? Azure activity logs, audit logs, like those are the important logs, right? So that doesn't mean, but there's going to be like other logs, like I don't know, Kubernetes logs. Do you really need your Kubernetes logs in your security environment? Maybe, maybe not. I don't know. But make sure you know who is the person writing the detections or the investigations if it's not you, and make sure they're getting the right data in the right place and they're actually using it. Have schemas available. What is the schema for audit log? You can click and open this and see it, but it doesn't give you a lot of like information about it. You can Google in Azure, you can Google like intra audit logs schema. If you put the word schema in Google, it'll actually come up with the actual pointer to it. I don't know what you do. If you didn't chat GPT, you probably get the wrong schema. AWS, there are some better schemas for some parts of the logs, like CloudTrail. Like CloudTrail has a particular schema, but CloudTrail is like all this a bunch of standard stuff and then a whole bunch of like custom resource by resource. And there isn't really great schemas for all of that. So make sure you go and gather that data. You have examples so that people can read and understand so they can build your detections. It is best if you can do data enrichment for some of your data, like especially your custom logs that you're pulling from places. But in order to do data enrichment for data that's coming in, you typically have to have a big enough team to support that. All right. So we turned on our intra ID activity logs. We did it for Azure. We said we can do diagnostic settings, but for AWS, I can use CloudTrail. And here's one thing I really like about how AWS does this. AWS, I can go to my top level organization and I can say turn on CloudTrail, which will give me all my activity logs to the API. But I can also say I want DynamoDB or Lambda or S3 and all of these other data logs. It's a ton of data. Like it'll flood your system. But in one quick place, you can go and turn these on. And what happens with AWS is AWS is almost like going into the hypervisor from underneath and grabbing that data. Whereas in Azure, I'm actually going into the resource through the user engagement and turning on a setting. So I'm more concerned about the Azure policy not being set properly. I'm less worried about that with CloudTrail because it just kind of does it under the hood. There are things that can happen with Azure policy turning on logging that it breaks. So got to keep that in mind. So you got to kind of work through that. But I like this about CloudTrail that they've opened this up over the last couple of years to get better logs. All right. So we've gathered data. So let's build our detection. We want to use detection as code pipelines, which just means I'm going to write code in some kind of format, and that is going to be transformed automatically and deployed into whatever my production detection environment looks like. There are some companies out there that have built pipelines for you. There are third-party processes, your SIMs and other things that allow for this. Some of them are easier to use than others. You're almost just going to have to probably cobble together your own. I feel like a lot of people I talk to, they just write their own in their own ways because what comes out of the box usually doesn't have all the data they want. The nice thing about detection as code pipelines is that I can check that into GitHub. I can do full history. I can see revisions. I can even add metadata. Like this detection was written by Shaun and it's only used for these kind of services and it points to this MITRE attack technique or whatever it is. So you can kind of add a lot of other stuff that's on top of just the analytic. And then make sure you have a place to test this. You want to test this locally if you can. Can be kind of difficult to do that. If you're running queries against Splunk, it's not like you have a local Splunk on your host system. So that can be difficult, but you might have a test Splunk. You can add linting, you can add all kinds of services to kind of make sure that your query that you're writing is in the right kind of format. But you really definitely want to sit in some kind of like non-production environment just to see if that thing works. And then also write code to initiate the attack so that you can automate that detection over and over again. Consider your detection as a production application and treat it like you would any other kind of production system. So in the particular, here's an example of a YAML code that is being used to create a detection. You can have unique identifiers so that you can track things over time. This is the account created and deleted over a short time frame that we were talking about. There's a nice little description of what this is for. Ooh, I like this. A reference that describes like where I can get more information about. That's really important. That's really great. And then this is what's being used, and this would be something like Sigma or some other kind of YAML-based query description that describes how to run a detection. I think this is actually from the Sentinel itself. And down here, you actually, and I cut it off, but you have the query itself that you would run with KQL. I can store this file in GitLab or GitHub. I can make changes to it. Then I create my environment. I also want to store my attack scripts near it and connect it to it. So like I would actually have in here a pointer to my detection script name so I know how to run the attack again. All right, so I want to deploy my environment, track that history of alerts. Every time this thing fires, do I know that it is firing and resulting in a true positive? I want to track that for every one of my detections. Because after a while, you're going to find that you're wasting more time worrying about these detections and trying to get them, people managing them, and they're not useful, and you're wasting time, you're wasting energy. So being able to track that history and figuring out how to do that in your pipeline up front is very helpful. Make sure you regularly test it to make sure that this thing actually works over time. You want to make sure that you connect your detection to an investigation. Can be really difficult depending on how you do your investigations. If you are documenting your investigation in a standardized format, you definitely want to include all detections that started the investigation and any detection that is related to the investigation. So maybe that there was a detection fired, it was a low, but it's actually part of the investigation as you go along. You may not have seen it right away, but include those so that you can figure out where your false positives are. All right. So in that, in that Sentinel file, I've got my actual query here. And these queries can be quite complex. This is written in KQL. You're going to have your own language. I'm actually a big fan of KQL, even though GitHub is a really big Splunk shop. And so our analytics teams, they write their stuff in Splunk. But KQL is becoming more and more prominent as a standard language. But anyways, this is written for Sentinel, so it makes sense it's in KQL. And one thing I can do with KQL up front is I can change my frequency or my period. I can really kind of hone in my detection. I don't have to just use whatever Sentinel gives me out of the box. And I can make those changes here, and it affects everything down below. If I was doing this as a detection as code, I would probably extract those variables out of the query itself and make them a variable that can be passed in at the deployment time so that I can make changes to that over time to kind of hone in. And because, maybe 1 day period is too big for your organization, or maybe it's too small because you do this on a regular basis, you create and delete, and you don't want to track those. Anyways, there's different ways you want to look at it. So this is an activity where you created something and then you deleted it. I'm connecting those two values together and I'm doing it over time. That is a very much more of a behavioral analytic. I'm seeing multiple things happening and I'm pulling them together. That is going to be more complex. That is going to be more error prone. It is much easier to alert every time somebody creates an account, but it's not very useful, right? Your IT operations should look really dull. A lot of times people have problems writing behavioral analytics because everyone's doing something completely different and they all have different behaviors. And that is a problem with writing complex detections. And so if you figure out that, hey, I can't really write complex detections because everyone's just going crazy over here, work on trying to create better structure through your deployment so that there's only one place in which users are created and they only created by that one thing. And it's happening on every 4 hours and it's very methodical and, you don't really do things outside of that. And that makes it very easy to detect when there's a weird activity. Work with your posture team to improve your detections. If you find that, It's very hard for you to detect when, let's say, a storage account. So storage accounts can be used as web servers. They're very quick, great web servers. And what you used to do is you used to basically store all your stuff in there and then just make it publicly available. Well, it's hard to tell if it's publicly available because it's a website as intended, or if somebody has flipped it and made it publicly available, they can steal the data. So, uh, Azure has other options. There are other ways of deploying a storage account that allows you to set it up for public accessibility, and that basically puts in a special container called $web, I believe, and puts a load balancer in front of it. And it's not really a public storage account, but it is publicly available through that load balancer. So you look at that and you go like, that's a website. Like, I know exactly what that's for, and it might be easier for you to write detections for weird activity when the rest of your environment is not so weird looking. All right, so next steps, pick a couple detections in your area that you have gaps, either vulnerability gaps or detection gaps. If you're really bad at doing something from a protection standpoint, maybe write some detections for that area. Don't over-engineer your detections code pipeline. I'm a big proponent of anything that software you write, you're going to throw away your first version. We're doing that. It's very weird. I wrote some stuff at GitHub, 3 things, I think, and we're throwing all 3 of them away this year, which hurts a little bit, right, from pride perspective, but it's better. We tested it out. It wasn't exactly what we needed. We need to make it better, and so we'll throw it out. It wasn't a big investment. So think about that. Throw out your first approach because you're probably not going to get everything you want the first time. If you try to, you're going to end up overbuilding something and you're not going to finish it. Constantly improve your process. Gather the data, inventory what resources you have, what you're detecting, what logs you've got to pulling back. Are you actually collecting from everything? Do you have tenants or accounts that have cross-account access that you did not know about? Investigate those. That will help drive you to where your detection is going to be. And think about detection engineering as a flywheel. Every day, you got to give it a little bit of a push forward to get that forward momentum in order to make something that is measurably improved. And with that, that is the end of my presentation. Thank you very much for attending. We're going to have more talks on detection engineering coming up in the future. We'll hit different sides of the detection engineering process with those. Please stay tuned with those. And otherwise, thank you for your time. Hopefully, I'll see you again one day.